Hi everyone, my name is Roman, I live here in Kyiv, so maybe you know me. I work in a company Attendify here in Kyiv, and today I want to talk about our real-world experience in building front-end in ClojureScript. So maybe you will learn something for yourself, some patterns, or maybe just see how React is being used in other languages. Okay. Works. No, it doesn't work. Okay. I think it's probably because of TeamViewer. Wait. Okay. Oh, it's good. Okay, so we have multiple products, and today I want to talk just about one of them. This is basically what we are doing is event management platform. So, for example, if you are an event organizer, you can use our platform to retrieve and aggregate and analyze all the data about your conferences, attendees, and whatever. So, Katya probably told you about Attendify app. So if you install it and find a React Kyiv event, if you join that event, so you can basically experience everything that we propose to our customers, and afterwards I will do a demo with all of the data that you posted in the app, so we can do something with it interesting. And also the one who will do the best social activity. As a present, I will give you a book about Lisp, so you can learn a little bit about schema language. Okay, so the UI structure of that project is more or less like this. We have a couple of pages. It's a pretty small project. A couple of pop-ups with widgets, forms. I will probably show you how it looks like on production. So, for example, here is the main view with all the attendees of React Kyiv right now in the app. We have 15 people here. For example, let's choose the first one, Anya. Okay, so we can see what Anya did today in the app. She registered at 10 a.m. Nice, good morning. Okay, and then she checked into the event. And then she edited the profile again, and then she posted at 8 p.m. a photo. Cool. Nice. Okay, so we can see information about the profile. As an event organizer, because it's account of event organizer, you can edit the profile. You can see. Sorry, I'm showing your email. You can see the history of editing. Yeah, you can filter the timeline. So there are a lot of features. You can integrate with different platforms like MailChimp or Salesforce. Yeah. Also, let's make a demo right now. So the main feature of this product is that when you're organizing a lot of conferences, you want to know what your attendees are interested in. So, for example, I want to launch maybe an email campaign for all developers that were attending my events. So I can find, for example, someone whose position is developer. Okay. So we have 5 developers here. So I can segment them. So I can create a segment of developers. And save it. And now I can, for example, integrate with MailChimp and send to all of them an email, or to invite them to other event and so on. Okay, so let's get back to slides. So this is how it works. Okay. Okay, the tech stack is partly JavaScript and ClojureScript. So as I told you, we have multiple projects. So basically, like the major part of the UI library is built in JavaScript, including some libraries like highcharts, for example, D3, React Virtualize for tables, React Select, Sortable Clock. This is all UI library, and in ClojureScript we mostly have like you can name it business logic, for example, and a little bit of UI components which are used only in Clojure projects. And this particular project is around 10,000 lines of code, or 1 megabyte of generated JavaScript, or 260 of JZip. And out of this 1 megabyte, we have around 200 kilobytes of ClojureScript runtime, which is all the data structures, because Clojure has its own data structures like set, hash map, list, vector. Also, application code is code that was written by developers is around 300 kilobytes, and everything else is helpers or some like utility libraries. So basically, 10,000 lines of code, you can write something like this in Clojure. Okay. Okay. So, how we do React? So, we are not using JSX because there is no such a thing as JSX, but instead there is a special syntax called hiccup. So the element is a vector, which is like array like the data structure, where the first element is a name of the tag, the second one is a hash map of attributes, and all the rest are children. So for example, here I create a component button, which is just a function that receives on-click handler, some label, and returns this definition of the button. So we have button keyword, on-click, and label. And then when we want to render it, we just call the function which returns the hiccup. And this is like the universal way to describe markup in Clojure, because it's also used as a templating language on the server when you're, for example, generating static websites. I thought it wouldn't work here. Yeah? Okay. For state management, we are using something between Reflux or Redux, but in the end, it's just an architecture around events. You're registering like handlers, you're dispatching events, then you handle them, change the state, and that's it. So we have dispatcher, reducers, which we are calling controllers, the global state, as in Redux, UI, and pub-sub mechanism. And probably as one of notable features, we have batched events on request animation frame. For example, if somewhere in the app you are issuing like 5 requests immediately, or sorry, 5 events immediately, they will be batched into a single state update, because it doesn't make sense to make a couple of updates to state like at a single time. This is like an optimization which you can do also probably in Redux or Flux. Okay. So how those controllers look like? So you can think, if you're familiar with Redux, you can think of controllers as Redux reducers, right? For those reducers, we are using the feature that is built into Clojure, which is called multi-methods. A multi-method is basically a function with multiple implementation. And you as a developer decide by which value you want to choose which implementation to run. So we have an initial state for the controller, which is a hash map of some, like, for example, it's a reducer which, or controller which handles products in the app. So we have an initial state with all the products, loading falls through when we want, for example, show a spin or something, and error. So here is the controller, and it defines init event, which associates an initial state into the global state, and then you have fetch by category event, which receives the name of the category, and for example fetches all the products by that category and dispatches done event. It's a little bit different from Redux, but maybe more like Flux. Sorry. Okay. And then we gather all the controllers into a single map the same way as in Redux. And when we want to dispatch some event, for example, products fetched by category, we just use dispatch function that dispatches against products controller, which is registered here, and this event. And everything else is arguments. And this special syntax is a shorthand. You can think of it like arrow function in JavaScript, for example. Okay, it works only 2 times. Routing. Routing is also a little bit different. We are not using any special libraries that handle everything, but we are using 2 libraries which does different things. One library is for listening to on-change event on URL, and the other library is to match route's definition against that URL. So, for example, this route definition is done in Clojure vectors. You can see that here we have root, and root path has an identifier index. For example, /contacts is contacts, /contacts then dynamic ID. It's going to be a segment, then something more complex. And for example, when the URL is changing in the browser, we are using that library to match route's definition against the URL, and then we get parsed description of the route. So here we can see that it's profile identifier with some parameters like segment ID and profile ID. Then we put that route into a global state, and somewhere in UI, for example, if you have somewhere a router controller or component, you take this data from the state and then match against it and render appropriate view, right? Okay. So it's all the same like in JavaScript. Another thing that you might be familiar with in Redux is a connect function that allows you to connect to some parts of the state inside of your components, right? So you don't do subscription in the root and then pass everything. You can just subscribe somewhere inside of the UI tree and subscribe that component to something in the state. So we are using the same, but it's more or less like connect, but it works a little bit different because it's using what's built in Clojure. There is a special data type which is called atom. This is a reference type which allows to change what's inside of it. Because all the data is immutable, we cannot hold state anywhere, but atom allows us to put something inside of it and then change it. And also it allows us to listen to those changes. So basically it's like a Redux store where you can put data and then subscribe and will be notified on every change. For example, here we have atom with profiles, with some settings, and then we're creating a cursor, basically an atom, which watches inside of that structure by that path, and it's profiles key. So we are creating a new atom, which holds only this part, and then inside of the component we subscribe to changes behind this data, and every time this part is changing, it will render the component, we will extract the data, and for example, if it's loading, we'll render spinner, or if items are there, we'll render the items. Yeah. And for example, in JavaScript, it's not recommended to use should_component_update too much, because unless you're using Immutable.js, for example, because on every should_component_update, you should do shallow equality of the props. So basically, you need to do for loop against all properties. But for example, if you're using Immutable.js or you are in Clojure world where everything is mutable, should_component_update check is it's super cheap. It doesn't take any time. So you can put it in every component. and it will not impact performance at all. Okay, and the next thing is, if you also work with Redux or I don't know React, maybe it can be used without Redux. It's a reselect library. Who knows what's reselect? Okay, someone knows. So basically, it's a library to aggregate and cache data. For example, if you have a single piece of data, profiles or something, but you want to render this data in different shapes. For example, you want in one part of your UI you want to render just the counter, which represents the number of how much profiles you have. And the other UI part should render all the profiles with all information about those profiles. So you have different representations for the same data. And here, and that's why people are basically using reselect, because you can just transform this data somewhere, but on every update you will run those transformation functions against this piece of data, and that can be a little bit expensive, and sometimes too much expensive. So, and libraries like reselect, they allow us to cache the output of this transformation, and then on every update, it just does a check, and like if the source data didn't change, so you don't have to run all those transformations again. Okay. So it's basically like aggregation and caching. And we have something similar in Clojure. It's something which is built on top of those cursors. Okay, it doesn't work at all. No, it works. Okay, so we have here a cursor. Next we have reduce cursor in, which is just a function which wraps that function and provides an API for selectors. So here we also have a pass inside of the structure, and the function, we call it aggregation function, which basically does some data transformation, and the value which is returned by that function is cached. So for example, let's say in this component I want to render the names of the first 100 profiles from a list. Because it doesn't, for example, I render a list, and I know that on the screen I can see, or for example, on the first page in the table, I want to render only 100 names of the profiles. So it doesn't make sense for me to transform the entire list of profiles. I can just transform the first 100. So here we create a function, we pass a number, give it first 100, and then the aggregation function will do all the stuff. And on every update, if, for example, somewhere between 100 and 200 the profile changes, this function, this subscription will not be, it's not going to rerun because first 100 profiles didn't change, right? So that's what we're selecting. That's how it looks like in Clojure. Okay, another part is communication with backend. So we are using GraphQL and also JSON RPC. GraphQL is mostly for projects where we have more than one client, for example, web and mobile. It makes sense to use GraphQL here because you can control from the client which parts of data you want. But for usual like web-only projects, we are using JSON RPC. And JSON RPC is basically you're sending all the requests to a single API endpoint, similar as in GraphQL, but instead of passing queries, you're passing like a command. For example, hey audience, give me all the profiles. And then you pass some data parameters, and when the request is done, we dispatch an event. So we have, as an optimization, we have automatic batching, because our API supports batched requests. Basically, instead of sending one request, you can send a hash map of requests with IDs, and they will be processed in batch and returned with those IDs. So in our case, if different controllers in the application want, for example, they are doing multiple requests at the same time. Like for example, from this part of the app I'm doing 2 requests, and from this part of the app I'm doing 1 request. They are not connected in any way, but the library which handles the network requests will recognize that we are doing it at the same time, and it will batch everything into a single request. We have also optimistic updates, but we are doing them manually. We don't have any like special instruction for it. It's super simple to do them by hand. And we're also using monads to handle errors because they are turned out to be very useful. I will talk about it later. Okay, so how the flow of optimistic update might look like. Who is doing, by the way, optimistic updates on their project? Okay, 2 people. It's going to be interesting for you probably, maybe you'll learn something. So what is an optimistic update? Let's say you have a profile and you want to edit the name of the profile. How we are usually doing it, you edit the input field, you hit enter, you do a request, you get response, and then you render the updated field. Optimistic update means that instead of waiting for response, I will update the UI immediately, and when the response will get back, I will check if it's an error, I will just roll back to the previous value, and if it's not an error, if it's okay, I will do nothing because the UI already updated. Okay? So that's basically what this fancy diagram is talking. So if I want to update a profile name, I'm issuing a request, immediately updating the state with a new profile name. For example, I have a profile ID and a profile name. So I'm searching for a profile by ID and updating the name. Then I'm doing a request, and backend if it's okay, I'm doing nothing. And if the response is error, I'm using that profile ID with old profile name to roll back the update. In the code, it looks like this. So we have an event handler for update event on profile controller, which receives ID, the old name, and the new name. Then we're sending the request, passing the new name, and immediately updating the name of the profile by ID. But when the request is done, we dispatch update ready event and passing old name as well, because we want to be able to roll back. So here, when we issue update ready, we're checking if response is error, then we roll back by updating the profile with an old name, which was passed here. Otherwise, we're doing nothing, just returning this stuff. That's it. Like, you can build something on top of it, but usually it's like, you can see it's like 5 lines of code. And by the way, if you have questions, you can just raise your hand and ask. We don't have to wait for the end of the talk, okay? Next, so, okay. So for error handling, we are using either monad. So you can think of it like as a coin. Either monad tells, hey, I'm a box with 2 types of value. Right value and left value. So basically, the either monad is just a coin with left side and right side. And as a rule, what's in the left side is going to be error, and what's in the right side is going to be a successful value. And you have, when you're using some library with monads, you usually have the API which allows you to wrap a value inside of that data type, and then special operators to check if that value is right or left. And then you can decide what to do next. Okay, so for example, one way of working with either monad, which is super stupid, there is like no point in using either monad if you are doing it like this. So our, for example, API library by default it returns the response wrapped in either. So we are receiving that response wrapped with either in this event handler. We are checking if the response is a right value. Then we extract the right value from the response and just put it in a state. But if it's not a right value, then it means that it is a left value, which is a failure. Then we extract the left value and put it in an error state, for example. So, like in this case, it doesn't make sense to use either monad because you are just reading the value. Okay, so when it does make sense to use it, so let's first see how we usually operate on values that, like on data that we fetch. We fetch some data, we put it in a state, it goes to UI, then somewhere in selectors or right in the components we apply some transformations, and then we render this transformed data. This is how you work with raw data. I will kill it right now. Oh. Okay. So with Azure Monad, instead of extracting taking the raw data right into a state, we just put the Azure itself into a state, then it goes to UI, and then we apply transformations wrapped in Azure. And then only like after those transformations, before we want to render, we can check if value is left or right, and then render it. What it gives us is, okay. So here, for example, we have Azure error or profiles somewhere in the state, and in different parts of the UI we are rendering those profiles which are going through different pipeline and transformations. So usually if we do some transformations on data, we have a couple of checks like if value is undefined or is array is empty and so on. And with Azure, for example, if there is an error or a successful response, with Azure we can use a map operator on Azure type. It doesn't do like mapping over an array, but it's an operator which allows you to pass a function which will take the value which is inside of the Azure, apply the function to that value, and then put it back. So basically, it's like a callback to a promise, right? You're extracting the value of the promise, processing it, and put it back into a promise in a Zen. So, and when we apply all of these transformations, in that case, if there is a left value, for example, error, those transformations will not be applied. And if there is a success, they will be applied. And only after all of those transformations, you can check if the value is left, then there will be an error. You just render an error, and those transformations are not applied. If it's a right value, then those transformations are applied automatically. You just render the result. You can say that it's the same as promise. Basically, yes, you can put a promise inside of the state, and then somewhere in the component you can take this promise. But the problem is that promise API doesn't allow you to extract data outside of the promise itself. You can read data outside of the promise only inside of the callback. And it means that you cannot like use this data and render it. Oh. Azure left. I think you need to check this. Yeah. Thanks. Okay. Yeah. So that's it. The only difference between Azure Monad and Promise is that you cannot extract value from the outside. There is no magic. Okay. The other part that we are using, and you might be also familiar with if you are using Redux and middlewares, you have here something like login. For example, for instance, if you have such a system that is based on events, there is no other way to debug this system, but you have to log what is happening. like, there is no way to debug, like to understand what is going on if you are not logging all events that are going through your system. So we have something similar, which is a function that lives between the updates of the state. And in the console, we are logging the name of the controller, the name of the event, the list of the arguments that were passed in with that event, and the state before the event was applied and after the event was applied. For example, here we can see that we are selecting a segment by this ID, and the URL in the state is changing from this path to this path. It's very useful. Okay, and here's how the code looks like. We are extracting the state before the update, and we are applying the update, and then we have a next state that we are computing a difference between those states and logging them into the console. Come on. Okay, one more interesting part is that from the client perspective, I mean from the browser perspective, the state of the system which lives on the backend looks like the, I don't know, like the same Redux store. We are like holding the entire server state of the app in a single hash map. So basically, you can think of doing requests on the backend is like sending update event on the backend. And on every request, the server gives back the entire state of the system. So it's like an immutable update of the server. So for example, when application starts, the client says, "Hey server, what's your latest state?" Server responds us with a huge hash map of all the data that is in our application. We render this data, and then when we want to update something, the client says, "Okay, I'm going to change this field, for example, that profile name field. What's your next state is going to be?" Server computes a new state and gives back the entire state of the system, and we render. The benefit of it is that we don't have to do like atomic or partial updates of the state. Instead, we can just receive the entire state and just replace it. Like in the ideal case, of course, because there are no ideal cases. Okay, and this also allows us to do like should component update as in React, but on network layer, because every update is immutable. We just can compare like the versions or the hash map of the with the state of the system, and say, okay, if this on this update nothing changed, I just don't want to update the UI. This is useful for us because we are not doing like real-time updates on WebSockets, but instead we are doing long polling, like issuing a request on the server once a minute. So for us it's very useful because if user doesn't do anything, like in 1 hour, for example, we don't update state. We still send requests, but we don't update the state. Okay, so I think that's it. Probably let's see who is going to get that book. Okay. Developers. Sorry, I'm not removing the developers. I'm just removing the segment. Okay. Yeah, and now because we don't have live updates, I'm not sure if it's updated or not because we have requests once per 1 minute. Yeah, that's the con. Oh, we have analytics here, and I think we have a leaderboard or something. We have profiles. Yeah, we have 15 profiles, and the top score is. Let's make sure, because I don't believe what I do. Oh, yeah. Okay. Okay. I will not give a book to that guy because we work together, so it's going to be not fair. The next one is Andrei Stashuk.
No, we're sitting together, so go to the third.
Sure.
Yeah.
You're sure you don't want it? Okay. Max, I'm not going to. Okay. Yeah. Here is the book. I have another one, but like from the same series of the books. If you want one, you can ask me. Maybe I will give you. It's basically a book with an exercises in schema programming language, so you can learn how to do all the patterns in Lisp. Yeah.